Hello guys, this is Dr. Maha again, and I'm still doing the organic revision sheets from the Corona quarantine. I hope the situation is relieved soon. Meanwhile, I would like to continue the organic revision for IGCSE. Maybe guys, you can have some benefit from those videos in this hard time. I hope you give me your opinion about the previous videos. If you have any questions, please write them down in the comments. And let's start with the first question about how can cracking of large alkane molecules can be done. So explain how the cracking process is carried out. Well, cracking is a very common process in organic chemistry to break down the large alkane molecules into smaller alkane molecules, and we get some alkene molecules as well. But how this process is happening? Mainly, cracking means breaking down. So mainly we are breaking down the large alkane molecules by heating, okay? And we just use regular pressure. We don't need really to put too much pressure into this reaction. With that being said, we have then to use a catalyst. So using catalyst to speed up the rate of the reaction. This catalyst could be porcelain, could be aluminium oxide, okay? So I would say aluminium oxide, or it could be porcelain, to get smaller alkane and alkene molecules. Okay. I really would like to give an example of that, though it's not required, but I'm gonna give an example of cracking. Let's start with C5H12. This is the alkane, which is the pentane. If I heat it using a catalyst, it can break down to give me, let's say, the ethene, C2H4. This is ethene. This is one of the alkenes that are possibly we can get by cracking. What will be left is C3H. Just do the math, guys. 12 minus 4 equals 8. So C3H8, which is the propane. So this is an example. It's not required, but I just thought to show you how cracking could be done. Give a chemical test to show the difference between alkene and alkane. Well, the difference between alkene and alkane, this is really a test of unsaturation. So they want us to describe the test of unsaturation, and this test is by adding bromine water. Bromine water is a red-orange solution, as we all know the color of the bromine, okay? Now what will happen? The result of the test, it will be the disappearance of the orange color, okay, which is decolorization of bromine water if alkene is present. But if alkene is not present, it's only alkane, I would say the orange color will not change with the presence of alkane, if alkane is present. Well, it's easy to say that, but hard to explain. And I really want to explain to you guys why the color of the bromine water disappear when there is an alkene present? I'm gonna explain that in terms of equation. Equation here is not required, but I really want you to understand how things go. So I'm gonna get any alkene. Let's say I have my ethene, okay? This is the ethene, it's one of the alkenes. I'm just gonna use it to show you why the bromine water colors disappear. Then I'm going to add the bromine water. Bromine water is just regular bromine liquid. What will happen here? I'm gonna use the red color. What will happen is addition reaction on the double bonds. So what will happen, this pi bond over there will be broken. Also the bond between the two bromine here will be broken. Then those two bromine will be added to the ethene. This is how it will end like. So after I break down the bond, that's my hydrogen, the other hydrogen, and that's the other hydrogen and my other hydrogen here. What will happen, as we said, the bromine water will be added to the broken pi bond. So one bromine here and one bromine there. So that will leave me having no more bromine water. That's why the color of the bromine water, which is brown, this brown color will disappear because our the orange brown color will disappear because I don't have this bromine anymore because it's already added to the ethene. The name of this molecule, really, that's like the AS level, but this molecule is called 1,2-dibromoethene, and as I mentioned, this is out of scope of the IGCSE. We will take that nomenclature or naming of the organic compound in details in the AS level. But I just thought to tell you why this bromine color, the orange brown color, disappear. Let's move to the next question. Alkenes such as ethene can be made into polymers. Complete the following to show how ethene molecules bond to form part of the polymer. That's a piece of cake question, as I always say on the polymerisation. When they give you the monomer and they want you to end up writing the polymer, all what we need to do simply is breaking the double bond, joining the monomers. That's it. So that's exactly what I'm doing. I'm breaking the double bond for each one. Okay. Here we go. Just copying. Okay. Then, if you notice, I'm ending up having only 1 to 3 bonds around each carbon. The fourth bond will be used to connect those monomers together. So now each carbon has 1, 2, 3, 4. This one also will have an extended bond that will join or will bond this monomer to another monomers to form the polymer that I want. This polymer name is polyethene. I mentioned in previous videos that I call the polymer or I name the polymer according to the monomers that it forms. And since this polymer is formed from ethene, so the monomer here is ethene. Okay, so the polymer name will be polyethene. And as you said, I'm just joining the monomers together. I hope that's clear and easy. Name the polymer formed from ethene, so it's simply polyethene. Explain one important problems caused by everyday use of this polymer. What's the polymer that, or what's the problem that could be happened from using the polyethene polymer? Well, usually all of those polymers are, and that's the first problem that comes to my mind when we are using polymers. Actually, guys, those polymers are plastic. everyday use of the plastic, since they are a non-biodegradable polymers or a non-biodegradable substances, they will not decompose, they will cause more pollution, they will cause the problem of littering and filling the, I'm sorry, where was the page? Okay, I think it's over there. Yes. So the problem that I'm gonna mention here about all of those plastics, that they are non-biodegradable. What does that mean? That means they will not decompose by bacteria. Okay, so they will cause a pollution problem and filling the landfill sites. So pollution problems, okay, in the landfill sites. Now, next, the other question should be, okay, the high demand for petrol octane can be met by breaking down longer hydrocarbons such as decane by the process known as cracking. We already came close to this process in the first question that we did in this tutorial. So that's another example. Decane is broken down by cracking to octane and hydrocarbon X. Okay. Apart from heat, what is used to make the rate of this reaction faster? We came across this in the first question, so I'm going to use the catalyst, any type of catalyst, to speed up the chemical reaction. Octane is a hydrocarbon. What does hydrocarbon mean? That's actually a common question. Hydrocarbon, from the name, hydro and carbon, so they are organic compounds that contain hydrogen and carbon. I'm going to add the word only. Only is very important word here. Why, guys? Because actually all of the organic compounds are made up of hydrogen and carbon. You will see it in most of the organic compounds, all of them. But if it only contains hydrogen and carbon, that is the hydrocarbon. So they are organic compounds made of hydrogen and carbon only. Don't forget to mention the word only. Give the molecular formula of the octane. Well, those numbers are, I believe, they're Roman numbers. Metha means 1, ether 2, propa 3, buta 4, penta 5, hexa 6, hepta 7, and finally octa is 8. So octane should contain 8 carbon atoms, and showing the formula CnH2n plus 2. The hydrogen should be 2 times 8 is 16, 17, 18. Okay. The good thing that they already drew for you here the structural formula, so you don't really need to coming up with it by yourself. You can just count the number of carbons here. You will find there are 8 carbons, 1, 2, 3, 4, 5, 6, 7, 8, and the hydrogen should be 18 if you count them. Okay. The hydrocarbon X is used to make polyethene. What is the hydrocarbon X? Actually, from the structural formula, I can see that the hydrocarbon X is the ethene. And this is what I'm gonna use to make the polyethene. So the name of X is ethene. What's the name of the process in which X it's changed into polyethene. This is addition polymerisation. Addition polymerisation, and we already explained part of it in the previous question when we were adding the monomers of the ethene together to form the polyethene. Even if you just wrote polymerization, you would get the mark. Oops. Okay. Oh, I don't know why it's not working. Just give me a second. Okay. Question 7. The question is about hydrocarbon. Here, guys, you just need to fill in the blanks. Okay. Crude oil is a mixture of hydrocarbons. It's formed from what materials that were trapped in what over a very long period of time. So basically, crude oil is made up of, I would choose organic materials that were trapped in sediment over very long period of time, hundreds of years, until those organic materials like sediments, like fossils, all of those organic materials over long time and very high temperature and pressure, they would change to crude oil. Okay. Then this crude oil, which is a non-renewable resource because it takes hundreds of years to form, to get or to separate the hydrocarbons from this mixture, we will go for the process fractional distillation. Okay, how is it done? Which fraction has the lowest boiling point and which fraction has the highest boiling point? Before answering this question, guys, I really want to go over the fractional distillation very quickly, just the idea of it. Just the idea of the fractional distillation. Well, fractional distillation, as we said, it's separating the hydrocarbon mixture. This separation is according to the boiling point. With that being said, we're gonna heat the crude oil so that all of it is vapor. So I'm vaporizing all of the crude oil mixture. Then this mixture will pass through this fractionating column that you see here. Then as you go up, what happens is that the temperature decreases. That means you start to get those who have the very, very high boiling point at the bottom, and then as you go up and the temperature decreases, so we said here, we mentioned that the temperature decreases when you go up the column, so I would expect to have those who have lower boiling point up at the top of the fractionating column. So here I would have lower boiling point compounds would be at the top. So which fraction has the lowest boiling point? That will make this question very easy to say that they are the gases, particularly the natural gas, though it's not mentioned here, so I'm just gonna write gases, and that has the lowest boiling point will be at the bottom of the fractionating column, which is the bitumen, because as we said, as I move up, the temperature decreases, so that fraction that has highest density is the bitumen. This is very simple what fractional distillation is. Okay, some of the fractions containing larger hydrocarbon molecules are used to make plastics, such as polyethene. Okay. What type of chemical change happens in the reaction A? Hydrocarbon molecules, large hydrocarbon molecules. Then I'm extracting the ethane over there. So I would suggest reaction A to be cracking or thermal decomposition. Actually, cracking is thermal decomposition because we are breaking molecules by heat. So cracking. Okay. Explain what happens in reaction B. Obviously, guys, reaction B is polymerisation. polymerization of, well, you know what, this is not ethane, C2H4, oh, that's a mistake in the sheet. C2H4 is ethene, okay? And this process where I'm getting ethene from hydrocarbon molecules is called the cracking. So here they want you to explain what happens in polymerization. Let's check how many marks on this question. 2 marks, yes. So I would explain polymerization where I'm using many monomers or many small molecules of alkene, breaking the double bond and then joining them together to form larger molecules or to form polymers, okay? That's it. So that's what we're gonna write. So it is joining many small molecules, which we call them monomers, okay? By breaking the double bond and joining them to form large or long chain molecule, which is called polymer. So certainly with all of this detailing you would get the 2 marks. Next. Okay. That's a nice question. I really like it because it's related to what happens in nature. Oh, okay. Let's go back to the question. Natural gas contains hydrocarbon called methane. This is a very well-known hydrocarbon, well-known alkane. Actually, methane is a CH4 and it's a gas. This gas has no smell and it's colorless, and it's used in some water heaters. So some water heaters use methane as a fuel. Many people could die from breathing those fumes produced by the heaters that have not been checked and serviced and maintained. Explain how these fumes are produced and why they are dangerous. Why methane, or why if methane is used as fuel, people can get suffocated, okay? Well, I'm gonna explain that in details, and as I said, many accidents I have personally heard about was because of the suffocating of methane gas. What happens, I'm gonna write the equation first, though it's not required, it just needs you to explain what happens, but I'm gonna explain what happens by writing the equation. I'm gonna do it in green just for you to know it's not required, just for you to understand. So this is the methane gas. It's burning, or it's used as a fuel. So fuel is mainly you are burning this methane gas with oxygen gas. Because this happens inside heaters, so it will be an incomplete combustion. Incomplete combustion releases most of the time carbon monoxide and water. Okay, just to carbon monoxide gas and water vapor. Okay, just to balance this out, I'm just gonna put 2 over here. Now it's okay, 2 over here, and I'm having now 2 oxygen. I will put then as well 2 over there. I'll have 2 over there to balance out the carbon. It will end up by having 2 times 4 is 8. I'll put 4 over here. 4 times 2 is 8, and I will end up by having 6 oxygen, so I will write 3 here. Now the equation is balanced. Okay. This gas is a poisonous gas. This gas, guys, called carbon monoxide. What happens when you inhale it, that it binds with the hemoglobin. Hemoglobin is in the red blood cells. Those red blood cells is what carry the oxygen from your lungs to all your body cells so they can use the oxygen to survive. What happens that this poisonous gas will block the hemoglobin, so your hemoglobin will not be able to carry any more oxygen, so you would die, you would suffocate. And this is really what happened. So the reason here, I would say, if I want to phrase it, that burning, I would say burning or using methane or burning methane or use it as a fuel, okay, will result of carbon monoxide formation due to incomplete combustion. Due to incomplete combustion. Complete combustion, you guys, just for your information, produces carbon dioxide, which can just go to the atmosphere. But carbon monoxide is a poisonous gas. It comes from the incomplete combustion. Why does incomplete combustion happen? Why not complete? Because there is a limited air supply inside the heater or insufficient oxygen, okay? And I think we should also write that carbon monoxide is a poisonous gas, okay, that causes suffocation. I don't have to go the details into how carbon monoxide are attached to the hemoglobin, preventing the respiration, because this is more like biology details, okay? For the sake of chemistry, this answer is enough. All right, okay. Let's check, what do we have here? That's the last question over there. Propane and ethene are both important hydrocarbons. That's very easy. This is the formula of the propane. They want you to draw the structural formula of propane. That's an alkane. So I'm just gonna draw the three carbons over there and just fill the hydrogens around. Each carbon should has 4 hydrogen around. That's it, we're done. And then the ethene is, as you see, 1, 2, C2 and H, 1, 2, 3, 4, H4, that's it. Then complete the table by adding the formula of ethene molecules and structure. Okay, we're done with this part. Ethene can be changed into plastic by the process of polymerisation. What's the name of the plastic formed in this reaction? Well, we already had answered this before, and this is the polyethene. Okay, and then what type of polymerization reaction is shown in this equation? It is the addition polymerization that we already came across before. So this is the addition polymerization. Polymerization can be written with Z or S. Okay, this concludes our video today. I hope it was useful for everybody in this time of everyone is staying home. I hope those videos are useful for you guys, and see you next videos. If you have any question, ask me. Thank you. Bye bye. See you.